Okay, now we're going to work with operations with radicals. A minute ago, we looked at to make sure our radicals were in our lowest form. And so that's what we're always going to look at first. Well, if I'm looking at these two right here, I'm going to say, you know what? That's the square root of 54. That's the square root of 12. They're not the same, so I can't add or subtract their coefficients. But I'm going to look to see if 54 is in its lowest form, square root of 54. So by doing that, I'm going to come over here to 54, and I'm going to do the tree. Prime factorization. Here we go. 2 goes into 5 2 times with 1 left over, so that's 27. Hey, then I'm going to say that's not prime, so that's going to be 3 times 9. So then I'm going to say that's prime, but that's not. That's 3 times 3. Okay? So now since this is a square root, I know that I'm looking for pairs. Well, there's a pair right there. So that's going to be 2 times 3. And what's left is 3 times 2 in there. So that's a 6. All right. Now let's come check out the 12. So let's do the 12. My phone's going to ding again, just so y'all know. Got 4 times 3. This 4 is not prime, so it's going to keep going. Oh, but look, prime, prime, prime. And there's a set right there. All right. So the 3 is there. We're bringing the 2 out, so we're going to multiply this 3 by that 2. And what's left over? The 3. All right. So that is going to be, we can already look and see that's a square root of 6 and a square root of 3. So I'm not going to be able to add my coefficients out here, but we can just leave them be. So that's 6 square root of 6 plus 6 square root of 3. And that would be my answer. All right, well, let's pick it up. What if I put another little dude in here? All right, well, I can tell right away that I know that these two are going to be able to combine because they both have square root of 12 in them. Okay, so I can go ahead and say, well, now look, I already know what this one's going to turn out to be. This one's going to be 6 square root of 6. I don't have to reinvent the wheel if I've already done it once. That's okay. Then I'm going to come right here. That radical and that radical are exactly the same. So I'm going to work with my coefficients. So that's a 3 plus a 2, which is a 5 square root of 12. Okay, now I'm going to check to see if there's a chance that I can combine with this one. I'm going to know from up there I can't, but that's okay. All right, so up here we know that 12 works its way down to 2 times 2 times 3, which means I get a pair of 2's that come out. So that's going to be 6 square root of 6 plus 5 times 2. Remember, I'm pulling the pair out. Times the square root of 3. Running out of room there, so I'm going to come over here to this. Oh, look at me. 6 times square root of 6 plus 5 times 2, because there's a 2 right there. And the 3 is left over. All right, so that means my final answer, Regis, is going to be 6 square root of 6 plus 10 square root of 3. Final answer. Okay? All right, let's come over down to this one right here. Now, again, this is going to be the same kind of thing, except wait a minute here. This guy has an X in him. Well, a minute ago, he had a 12 and a 12 underneath the radicals, so I combined them. But this guy has a 12x, so he cannot be combined with that guy. He has to just stay by himself. All right, I'm going to cheat and look back up here and know that this part right here is going to get to be 6 square root of 6 plus 6 square root of 3. And then I know that that's going to break out to be 2 times 2, because remember up here, and then the square root of 3 is left. So plus 2 times 2 is 4 square root of 3x. Did I say that's 18 right there? Oh no, here it is. I'm crazy. I did it down there on my next problem that you can't see anyway. So see, shh, don't tell. So there's 4 square root of 3x. So that would be your final answer, because these can't combine and these can't combine. Nobody can combine. Okay, so now I'm coming up to the next part. All right, see how you do on this one. Try this one. I'm going to leave that up there so you can kind of look. Okay, hopefully you have done it, unpaused, and come back. This is like saying -1 square root of 2. And this is -3 square root of 2. So I already know I can combine these two. So that's a -1 minus 3. So that's a -4 square root of 2. But I don't know about this one. I'm not sure if I can bring him down to a square root of 2 as well. So I'm going to go see. So I got 2 times 9. Snapola, the 9's going to be a perfect square. So it will come out. So that's going to be 3 times 3, because this pair is coming out. And what's left over is this guy, square root of 2. So that's going to be plus 9 square root of 2. I know that looks like an A. I know I'm terrible at that. All right, so -4 plus 9 is really 9 minus 4, which is 5 square root of 2. And that's your answer. Did you get it? Hopefully you did. All right, let's go to the next one. All right, take a pause. Come back to this one. All right, here we go. 27, I think we did that one a minute ago, is 3 times 9, which is 3 times 3. So there's my pair. So that's going to be 2 times 3, bringing that 3 out. And what's left inside? This guy. All right. Plus 2 square root of 3. I'm going to go ahead and work this guy out just to make sure, so I don't have to come back and redo if I don't want to. All right, so then the 12 is right here. That's going to be 3 times 4, and I know 4 is a perfect square. So this 2 is going to come out and be multiplied to this guy right here, and what's going to be left is this 3 inside here. Hey, yay me! Look! They're all square root of 3. So that means I can add and subtract or combine all of the coefficients. So that's going to be a 6 square root of 3 plus 2 square root of 3 plus 6 square root of 3. Isn't it funny how these two ended up being the exact same thing, even though they didn't look that way to start with? Kind of weird, isn't it? Ow. Okay, so here we go. So I'm going to say 6 plus 2 plus 6. So 6 plus 6 is 12, plus 2 is 14. And then this is, remember, just like our variable, it just kind of hangs there. Square root of 3. Ta-da, ta-da-da, ta-da-da, ta-da-da. All right, one more thing I want to show you, and then we'll move on, is if you have the variables underneath the radicals, it works the same kind of way. All right, so if I have 3 square root of 27a cubed. All right, remember that 27 can be broken out into 3 times 9, which is 3 times 3. So that's left. Why do I put a bunch of 3's here all the time? Let's make that a 5. Because that's too many 3's, isn't it? Yes, it is. So I'm going to break this out. I'm going to say 5 times, here's this 3 right here. And then square root, what's left over is this 3 right here. But wait, I got this a to the 3rd power, which means there's 3 a's. Well, I need a pair because that's understood to be a square. So I'm going to pull this pair out, put it right there, and that leaves 1 inside. Yeah, 15a times the square root of 3a. Oh, yeah, I did. Okay, well, what if we had had that as the cube root? What if that was the cube root? So let's say 5 cube root of 27a to the third power. All right, well, we know up here that 27 works its way out to be 3 3s. Well, right here it says I'm looking for a triple pair, instead of just a pair, a set of 3. Oh, well, there's a set of 3. So that means that guy comes out. And there's nothing left in. Over here, that we were only looking for a set of 2. But here we're looking for a set of 3. And it's all based on this root right here. All right, we're going to do the same thing with the a cubed. Well, it is a set of 3. So that means we bring one of the a's out. Anything left over here for the 27? Negatory red leader. How about here? Nothing. So it's just going to be this right here. So my answer is 15a. Yeah, I did. Yeah, I did. Yeah, I did. Yeah, I did. Okay, so let's try one more. Let you try it on your own. See if I can think of one. All right, so here's on your own. So I'm going to have 2. Well, we'll do 2 more. 48a to the 5th power. All right, go ahead. Okay. All right, I'm assuming you are already back. So that's 2 and 24. Again, 2 and 12. 2 and 6. 2 and 3. Okay, we're looking for sets of 2 right here. So here's a set, and here's a set. So that means a 2 comes out right there, a 2 comes out right there, and then this guy comes from right there. Now what's left over? The 3. All right, let's come over here and do this with the a. So we've got a, 1, 2, 3, 4, 5. We're looking for sets of 2 because it's a square root. It's 1 set and 2 sets. So 2 of these come out and 1 gets left in. Okay? 2 times 2 times 2 is 8. A squared. 3a is left inside. All right, so that means I did that so that if I had something else over here to where it was like plus 2a squared cube root of 3a, then that means I can say, okay, this is an a squared, this is an a squared. Under here is 3a, under here is 3a. So all of these are the exact same except for the coefficients right there. So I could add my coefficients. All right? Sounds simple enough. Go try some of it. Please, please, please contact me and we will work on teams to see if I need to help you at any. Have a good one.